Hello guys, welcome to learning microcontrollers. In this video I'm gonna show you how to interface a PIC16F877A microcontroller with a motion sensor. The motion sensor I am gonna use is HC-SR501. It's very easily available in market and it's a cheap sensor. It looks like this. You can easily buy from any electronic store and it is very easy to use. Let me show you how to use it. So from back side it looks like this. This is its front side and this is the bottom side. From bottom it looks like this. Here you can see that there are 3 pins in the center. If you hold it like this, in this formation, the right pin is the 5 to 12 volt pin. You can give voltage in between 5 to 12. You can give 5 volt, you can give 6, 7, 8, 9 and maximum is the 12 volt and minimum is the 5. This left pin in the same configuration, the leftmost is the ground pin. You connect it to the common ground of the circuit, while the center one is the output pin. From this pin you take your output. Maximum output voltage is 3.3 volt. So guys, apart from this, you will see that there are 3 pins here on the left, 1, 2, 3, and you can see a jumper on it. Now if you place a jumper on the first 2 pin, this brings this module in the H mode, that is a high mode. And if you put the jumper at the bottom configuration, bottom 2 pins, that is 2 and 3, in this configuration the sensor comes in low mode. Now let me tell you what this high and low mode means. So guys, in high mode, that is H mode, this is your proximity sensor, and whenever a hand comes in front, like a motion is detected, the output will go high, but output will remain high for as long as the hand is in front. As soon as the hand is removed, the output will go low like this. This time, for how long the output will remain high, depends upon the time delay adjusted from this potentiometer. If you hold the proximity sensor like this, the upper one in this holding pattern is the one from which you adjust the time delay. This time delay depends upon this potentiometer. You can increase this or decrease this depending upon your need. Now what happens is that as soon as there is no motion is detected, the output remains low. Whenever the motion is detected again and hand is in front of it continuously, in this case in high mode your output will remain high and with the same time delays as long as the hand is in front. It will only go low when the hand is removed. But so we can say that in high mode you get the multiple outputs, multiple pulses like this. But in case of a L mode, now we see what happens in the L mode. In the L mode, this is your proximity sensor. As soon as a hand comes in front, your output, which is low normally, goes high, and then it will remain high for how long? It depends upon how much time delay you had given using this potentiometer. It will remain high for that time, and after that when the hand is removed, it will go low, and it will remain low for as long as the hand is removed. And again the hand comes in front, the output goes high, and it will remain high for as long as the time delay adjusted from the same potentiometer. But in the low mode you will not get multiple pulses. It will go low after completing the time delay interval, and then it will go high again. It will go low, like it will get to 0, then it will go high, then go low, then go high. It will keep on going like this, like it will generate a 1 pulse at a time. While in the H mode it will keep on high. So it depends upon your requirement, whatever you want to do. So these are the 2 modes of the sensor, easy to use and easy to adjust. Now this range of this proximity sensor can vary from 3 to 7 meter. You can adjust this sensitivity or range from this potentiometer. By rotating this potentiometer you can adjust the sensitivity and range of your proximity sensor. So guys, I showed you how to use this in some basic demonstration. Now let me show you how to connect it with a PIC16F877A microcontroller and program it using a MikroC for PIC programming compiler. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is our sensor from the bottom side. It looks like this. Now guys, as told you earlier, it got 3 pins. If you hold it like this from the bottom, then the right pin is the ground, the center pin is the output pin, and the left pin is the VCC. As told you earlier, 5 volt to 12 volt. You can give minimum 5 and maximum 12 volt at this pin. And guys, we connect ground directly with the ground of the PIC. VCC will go to the VCC of the PIC because they will be the 5 volt. And output, you can use any available ADC pin of the PIC16F877A microcontroller for this. I am gonna use pin number A0. You can also use digital input output pin depending upon your project, but in this project I am gonna use an ADC pin like this. Now guys, apart from this, I am gonna display the output on the LCD. So this is an LCD I am gonna use. This is a 16x2 LCD with backlight. So let's see how to connect it with the PIC. To connect it with the PIC, you will need a 10 kilo ohm variable resistor. So this resistor has 3 pins, 1, 2 and 3 like these. Now let me show you how to do the connections. On the LCD you have 16 pins from left to right. It's 1 to 16 if you hold it like this. Here you connect pin number 1 and 5 of the LCD, then you connect it with the pin number 1 of the potentiometer, then you send it to the common ground. Then pin number 3 is the adjustable pin of the LCD from where you adjust the contrast using this potentiometer. You connect it to the adjustable pin of the potentiometer, that is pin number 2. Then pin number 3 of the potentiometer and pin number 2 of the LCD will go to the 5 volt pin of the PIC, that is the VCC pin. So in this way, potentiometer LCD both will get the 5 volt along with our proximity sensor as done earlier. Now pin number 4 of our LCD is the RS pin. It's a reset pin. You can use any available digital input output pin of the PIC16F877A. For this I am gonna use pin number C0, that is pin number 15 of the PIC. And for pin number 6, that is enable pin, I am gonna use C1. For pin number D4, that is pin number 11 of the LCD, I am gonna use C2 of the PIC. For pin number 12, D5, these are data pins. Data pin 5, I am gonna use pin number C3 of the LCD. For data pin 6, I am using D0. For data pin 7, I am using D1 of the PIC16F877A. Now guys, 15 and 16 pin of the LCD are for backlight. LCD will work even if you do not use the backlight. But this LCD supports the backlight, so I am gonna use the backlight. So pin number 15 is the 5 volt pin. You connect it to the 5 volt pin of the PIC16F877A. 16 is the ground pin. Just send it to the common ground of the PIC. In this way our LCD is connected. Now these 4 pins, 7, 8, 9, 10, they will go empty. We are using LCD in a 4-bit mode. If you use it in a 8-bit mode, then you need to connect these. It depends upon your requirements. So guys, these are our basic connections. In this project, what I'm gonna do is that I will program this in such a way that as soon as a hand comes in front of the sensor, then LCD will display motion detected, else it will say clear. So this will be a basic project. So let's get to our MikroC for PIC programming. So guys, this is our MikroC for PIC. So let me show you how to use it. I'm using the version 5.611. You can use the higher version as well, but there are some small changes which you can do to make the same code work. Okay, click on File, New, then click on Next. Write the name of the project. I write proximity detection using HC-LM learning microcontroller. So the microcontroller I am using is a PIC16F877A. Crystal is 20 megahertz. Select this, click on Next, Next, Next and Finish. Now first of all, we will need to initialize the LCD. For that, you go to the right. There is something called Library Manager. In the Library Manager, you go down. Here you have this LCD, Here you have this LCD INIT. Click on it. After that, in the example below, you will see these commands. You copy it from here till here. You copy it, then you go back, you paste it above the void main. Now here you know what we had done. We had initialized these pins. RS pin as C0, EN pin as C1, D1 for D7, D0 for D6, C3 for D5 and C2 for D4. Now we do the same for the direction pins. Here too, RS pin, let me remove this. RS pin is initialized as C0. Right here C0. Then we have C1, D1, same as above, because those were pin outs and these are pin directions. Then we have D0 for D6, for D5 C3, for D4 C2. If you use any other pin configuration other than the one I had selected for LCD, you simply have to change these pins. For RS, whatever pin you select, like B1, B0, B2, any pin like of a port D7, D6, it depends upon you. Now guys, we got our pins initialized. Now we initialize LCD. To initialize the LCD, write this command LCD INIT. This is a command which will initialize the LCD. Give some delay. I give 250 millisecond delay for this. Now the second thing is we are using an ADC module, ADC pin as well. For that we will need to initialize our ADC module. For that use this command ADC INIT. This command initialize all the ADC pins of the PIC16F877A. So now our ADC pins are initialized. Before we continue, we do not need the cursor on the LCD, so we remove the cursor. For that, go to the right again. Here again you go to this command LCD CMD. In the LCD CMD, in the example you have this command, you copy it, paste it wherever you want, like after ADC pin. Now you go back again to the library manager, again to the LCD CMD. In the available command list that is here, look for this command, turn off the cursor. This is the command here. You copy it, paste it inside the bracket like this. Now this will turn off the cursor, give some initialization delay. 100 will be enough. Now we clear the LCD if there are any ragged values before we move to our programming forever loop. So this is the command which will clear the LCD. You copy it, place it like this, give some initialization delay. 10 will be good. Now guys, the next thing is we go to our forever loop now. For that, write while 1. Forever loop starts here and ends here like this. Now in this we write, first of all we will need to read the value from our sensor. To read the value from our sensor, what we gonna need is a variable which will store the value. So we need a float here. Float read 1, it will store the value read from the sensor. But problem with the float is that our LCD cannot display a float directly. For that we will need a string. So we also initialize a string char read 11 a 5. Oh, sorry, 5 will be do fine. 5 means it's like 0, 1, 2, 3, 4, 5. There are 6 digits. Like this is a string array of 6 digits. We had just initialized this to display the value on the screen. So first of all we write read 1. Now we read the value from the sensor. For that write ADC read from which channel? Channel 0. The sensor I had connected, that is the output pin of our motion sensor, is at pin number A0. So because of this I wrote 0 here, because it will read data from channel 0. Give some initialization delay, just copy paste it here. 150 will do fine like this. Now guys, we cannot display this directly on our LCD. For that we will need to convert it to a string. For this you use this command float to str read 1 to read 11. Read 1 is this variable which will store the value read from the sensor, and read 11 is the variable to which it will be converted. Now this is a char, as I told you earlier. Read 11 is here and it is a char. It's an array of string. So now guys, I give some initialization delay to this command as well. 50 will do fine. Now we display it on the LCD. To display it on the LCD, use the command LCD out bracket, start writing from first row, first column, what read 11. Sorry, we will need a comma here like this. Give some delay for how long the value should be displayed before new value overrides it. I give some like 200 or 250 will be fine. For 250 millisecond it will keep on displaying the value. Okay, we click on write. Okay, it gave an error. Float, we need 2 T's here, like we missed 1 T. Click on build again. Okay, code is successfully built without any error. This code will only show us the value on the screen, whatever is read from the sensor. Then we will use that value to calibrate it as we need to display like optical detected and clear values rather than the ragged values. So let me introduce you to our hardware. So this is the hardware guys we are using here. This is our sensor. Here you can see this is a sensor and this is LCD, and in front there is our PIC16F877A microcontroller. Let me show you. This is our PIC16F877A microcontroller there. So guys, let's do the programming. So I go to PIC3 programming software here. On that, let me zoom in. Go to File, Import. Here the code I just wrote is this: proximity detection using HCLM. Click on Open. Now click on Write. Okay, the new code is being written. As you can see, it is writing the new code. PIC 3.5 is the one I am using here. So let's see what happens. Okay, the new code is written. Now I power it up using a PIC. To power up, here you have this. You click on this on button. Now it's powered up. See, we are getting racked back values. It's showing 0, 10 because there is nothing in front of it. I bring my finger in front of it like this. Let's see. And we are using the proximity sensor in the low mode. Okay, my hand was too near. You need to be a bit far away like this. See, it goes up to 712. 712 is the 3.3 volt. Like this, I place my hand in front. See, the value will go up. Okay, I wish you can see. Okay, this is my hand. See, it got to 713. In the normal state, the value is low. We are using the sensor in low mode. Now I again bring my hand in front. See, the value goes high, then it goes low. I had set a time delay to be very short. See, it goes up and then goes low. See, that is what is happening here. Goes up and goes low. Now again I bring my hand, it goes up, it goes low. So from this you can easily predict that it is a value like 713 is a 3.3 volt in ADC terms. So it will be like above 600 the motion is detected. It's my hand in front of it. I am sitting right next to it. So it gets sometimes the value. See, now I again bring my hand in front. So it goes up and then it goes back to normal. This up time, high time depends upon this potentiometer here. You have to adjust it using a potentiometer at the other side. Now guys, what we do is that we calibrate it. Go back to your programming. Here, zoom in. Here what we gonna do is that we no longer need to display these values. So we delete this. We write if read 1 is greater than 600, it means motion is detected. So we will display this. Start writing from the first row motion detected like this, and give some delay so you can see the value easily. Like 100 will be enough, like this, or make it 200 so you can at least it should be readable, or 250 will be fine. So for 250 millisecond it will keep on displaying motion is detected. Now you can match both of these delays with the delay set from the potentiometer if you take some time with it. So guys, and in case the motion is not detected, then it should display else what it should do, it's clear that there is nothing on the screen. We no longer need this as well, so you write else here, start writing from the first row, first column, clear. But remember how many digits are here in motion detection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you do the same here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is necessary. Else, when it will override this, what it's gonna do is that it will show clear here, clear, and rest detected will remain here at this place. So you have to clear it. So when it overrides it, it replaces them with the blank values. This looks more presentable. So let's burn this code and see what happens. I build it, and let's click on write. Let's go back to our hardware. This is our hardware here. Let me zoom out. See, it's at 0:13, like no motion is detected. I bring my hand in front. See, now it will show the motion is detected. See, the motion is detected. It goes up for some time. This is the time delay I had set. Now my hand is in front, computer is right next to it, so it's showing some random motion when I place my hand on the mouse. So let's run our new code and see what happens. Click on write. Okay, I hope I build the code. You have to click this button, build button, else the code will not be updated. Okay, let's see what happens. Okay, our new code is burned. Let's go back to our hardware. See, it's showing clear now. That it's now the motion is detected. When I bring my hand in front, motion detected. Now it goes back to clear. Again I bring my hand in front, motion detected. Then it's clear. I keep my hand in front, it says motion detection, and then it goes clear. See, motion detected when the hand is in front. It only gives one pulse because we are using it in a low mode, L mode. So if you want to show it that it should remain motion detected when the hand is in front, then you use the H mode. So again I bring my hand in front, motion is detected. It can detect motion from very far, like when I place my hand here, that's far away, it detects the motion. It's like here, detects the motion. See, again the motion is detected easily. See, motion detected. It has number of applications, especially wherever you want doors to open from human motion. It basically works on infrared and detects the heat of a body. See, I bring my hand, it says motion detected. If you want to increase this time that it should display motion detected for longer, you go back, you increase this delay. I make it 600. Now it will display motion detected for a longer time. Click on build, go back to the hardware, to the PIC16F877A programming software. You click on write again. Now the code is being updated again. Let's see. You will see a little bit of difference here now. See, the new code is burned. Now see, it shows motion detected for a longer time. See, motion detected for a longer time. I simply change the delay. If you want it further longer, you can simply change the delay further. So guys, I hope you learned something from this video. Thank you very much for your time. If you have any queries, you can ask in the comment below. So have a nice day and see you in the next video.